Science classes by Ganesh Hebbar. So today's topic is class 10 physics, chapter number 12, some of the numerical problems, the continued part, that is part 2. The next problem which is asked is several electric bulbs designed to be used on a 220 volt line. So there are several electric bulbs which are to be designed such that they are used in 220 volt electric supply. So they have given that V is equal to 220 volt. That is one thing. Are rated as 10 watt. That is rating. So rating is equal to, that is nothing but the power. Power is equal to 10 watt. How many lamps, how many such bulbs can be connected is a question. How many is the question. So what is the condition? How many such lamps can be connected in parallel? They need to be connected in parallel. Many such n number of bulbs to be connected in parallel across the two wires of 220 volt. If the maximum available current, that is a main current through the circuit, that is equal to I, which is equal to 5 amps. This much is the given value. So let us draw the diagram for this. So let us assume that there is a bulb. So there are different n number of bulbs which are connected in parallel. Let us assume bulb means there is some resistance. This is one bulb, this is one more bulb, this is one more bulb. Like that, how many? N number of bulbs. N number of bulbs are connected. How? They are connected in parallel like this. They are connected like this. How many? N number of bulbs. To what they are connected? To a 220 volt line. So they are connected to a 220 volt line. This is the 220 volt line. That is 220 volt. This is positive and this is negative. And provided if the maximum available current means it is nothing but the main current. Main current I is equal to the current which can be flown here. That is, this is called as the main current I, which is equal to 5 amps. That is the question here. So now how to find out this particular value? Main current should be 5 amps and the total actual voltage will be 220 volt, and like that 10 watts of many bulbs are connected. That you need to find out how many. That you need to find out. How to find that? We have P is equal to V into I, or I is equal to, that is P by V. What is, say for example, what is this I? I is nothing but the current flowing through the each bulb. Say let us assume I1 is equal to how much? P1, first bulb, power of the first bulb divided by the potential. Potential is the same everywhere. So it is P1 is nothing but 10 watt divided by 220, which is equal to 1 by 22 amps. That is I1. But I2, if you take every value, you will get same. Why? Because P1, P2, P3, everything is same. So it is also 10 divided by 220. That is, I end up getting 1 by 22 of amps. That means all I's, that is I1 is equal to I2 is equal to I3. All the values like that is equal to IN will be equal to 1 by 22 of amps. That means now we got to know that the current through each resistor or the each bulb is the same. I1, I2, I3, etc. Now they have given the main current. Main current is given by I. I is equal to, we have the formula in parallel combination. In parallel combination, main current I, current gets divided in parallel combination. So I is equal to I1 plus I2 plus I3 plus etc. IN. This is the formula for parallel combination. But we have found that I1 equal to I2 equal to I3 equal to IN, which is equal to 1 by 22. So shall I write this as I is equal to I1 plus I2, everything is same. That is 1 by 22 plus 1 by 22 plus 1 by 22, like that. How many times? n times. So that I can write it as, how to write this? This I can write it as, that is I is how much they have given it. So that is 5 amps. Main current is 5 amps, which is equal to 1 by 22 plus 1 by 22 plus 1 by 22, like that n times. That is n by 22. What is the n here? It is the number of bulbs which we have connected. So that only we need to find out. How to find? So cross multiply. N is equal to 22 into 5, which is equal to 110. So n is equal to 110. That is the answer for this particular question. The next question asked is, an electric lamp where resistance is 20 ohm. So electric lamp, the resistance of the electric lamp is given, that is 20 ohm. That I will take lamp as, I will take REL, resistance of the lamp, that is equal to 20 ohm. And a conductor of 4 ohm resistance. So I will take that conductor as RC. Why? Because it is conductor. So RC, which is equal to 4 ohm. These are connected in series. So they have given that they are connected in series. How to connect them in series? This is the method. So this is R1 or RL. This is RC. Both are connected in series to what? To a 6 volt battery. So battery is 6 volt. Then first sub question they are asking is, the first sub question is the total resistance of the circuit. How to find out the total resistance of the circuit? Total resistance in a series combination RS is equal to R1 plus R2. We already have that formula. So but R1 is nothing but RL plus R2 is nothing but RC, which is equal to RL is how much? It is 20 ohm. 20 plus RC is 4, which is equal to 24 ohms of resistance. That is the answer for the first sub question. What is the answer for the second sub question? That is B, the current through the circuit we need to find out. What is the formula? From Ohm's law. From Ohm's law, there is a law called Ohm's law, that says that V is equal to IR. So how to find out the total current? We need to find out I. Current is nothing but I. I is equal to V by R. But what is V? V is given here, that is 6 volt battery. So 6 divided by R. R is nothing but the resistance, effective resistance of the series combination of these two resistors. That is, we have already calculated it as 24 ohm. So that you need to substitute here. So that is 24. 6 ones are 6 fours are. So which is equal to I is equal to 1 by 4, which is equal to 0.25 amps of current will be the main current. That is the answer for the second sub question. And what is the third sub question? In the third sub question they have asked two values. First one is the potential difference across the conductor as well as the potential difference across the conductor as well as lamp. So I will find out the potential difference across the lamp first. So VL in a series combination, the potential difference gets divided. So VL is equal to I. Current is the same in series combination. So I into RL, which is equal to, what is I? I is equal to 0.25 into RL. What is RL? Resistance of the lamp, which is nothing but 20. 0.25 into 20 is 5 volt. So VL, potential difference across the lamp, equal to 5 volt. And one more is asked, that is potential difference across the conductor we need to find out. The formula is I into R, but I is kept constant in series. So I into R, which one? RC across the conductor. So I is equal to 0.25 and the resistance of the conductor is given, that is how much the resistance of the conductor? It is nothing but 4 ohm, which is equal to 0.25 into 4 is 1. What is asked? That is the potential difference. Potential difference unit is 1 volt. So answer is VC is equal to 1 volt, VL equal to 5 volt, total current is 0.25 amps and the total resistance is 24 amps. This is the answer for this particular question. The next question which is asked is, The current drawn by an electric heater coil is 2 amps from a 220 volt source. That is, they have given values are the current drawn, that is I is equal to how many amps? 2 amps from a 220 volt source, that is V is equal to 220 volt source. Calculate its resistance. R is equal to how much is the question. Direct question. And one more is, if I is equal to 1 amp, find the potential difference. V is equal to how much? That is also asked. So now we need to calculate this. I is equal to 2 amps. So V equal to 220 volt. So V is equal to, from Ohm's law, we have V is equal to IR. So V is nothing but 220, which is equal to I. I is 2 into R. So R is equal to 220 divided by 2, which is equal to 110 ohms of resistance that particular electric coil will have. 120 ohms of resistance. So R is equal to 110. Sorry, not 120. It is 110. Then next question is, if I is equal to 1 ampere, V equal to how much? Remember, it is an electric heater. Heater has not changed. Only current drawn by it has changed. If it draws 1 ampere of current, find the potential difference. If it draws, they have given, that means resistance is not changing. Only changing is the current which is to be drawn by that particular heating coil. So what we need to do is, so R is given, that is 110 ohms only. I is equal to 1 amps only. So what is the potential difference? That we need to calculate. I hope the answer, say for example, V is equal to IR. So we have the R, we have I. So V is equal to I is 1 into R is 110, which is equal to 110 volts. So V is equal to 110. If the current is 1 ampere, then the potential difference is also decreases by, here the current has decreased by, that is half, by decreased by half. That is why potential difference also has decreased by half. That is the answer for this particular question. The next question which is asked is, an electric iron consumes energy at the rate of 880 watt when the heating is at the maximum. That means power consumed will be maximum. The maximum power consumption is 880 watt. It is given when heating is at the maximum. And at the rate of 660 watt. That is 660 watt when the power consumption will be minimum. That is minimum power consumed is 660 watt when the heating is at the minimum. The voltage V is equal to how much? 220 volt. They have already given. Then what are the currents and resistances in each case? So we shall see this. So we know that power P is equal to V into I, or else I can write I is equal to P by V, or which is equal to power P is nothing but 880. That is, we shall take the maximum first. P maximum divided by V. 880 divided by, it is 220. So 0, 0, it is equal to 4. So 4 amps of current will flow in the circuit when the power will be how much? Maximum, that is 880. So when amps I is equal to 4, what is the resistance? Resistance R is equal to, so what is the formula for resistance? V by I. So V by I, that is V is equal to IR. So R is equal to V by I, which implies V is already given, that is how much? 220 volt, that is 220 divided by I is how much? Just now we have got the value, that is 4. So which is equal to 220 by 4 is nothing but 110 by 2, or which is equal to 55, which one? Ohms of resistance. That is when the power is maximum. When the power maximum, when power is maximum or heating is maximum, resistance equal to 55 ohms and current is equal to 4 amps. Current is equal to 4 amps. So it is 4 amps. Next is we have to say power equal to minimum. So when power is minimum, P minimum is equal to V into I. That is, or I can write I is equal to P minimum divided by V, which is equal to P minimum is 660 divided by V. V is nothing but how much? What is the value of V? So already given it is, that is 220. So which is 2 gets cancelled, 22 ones are 22 threes are. So it is equal to 3 amps. I will be 3 amps. Then so what is the formula for resistance? Resistance will be V by I. So which is equal to V is already given 220 divided by I is how much? I will be, it is already we have find out. So how much it is? 3. So the value, I will write it properly. Yeah, that is 3. So which is equal to, what is the value of 220 by 3? I will calculate it just now. Wait, I will calculate, and so it will comes out to be equal to 73.3 ohms. So power, when the power is maximum, resistance is equal to this much and current is equal to this much, and when heating is minimum, then power is equal to, sorry, not power, so they are asking the current. So current I is equal to 3 amps and resistance will be equal to 73.3 ohms. These are the answers for this particular question. The next question which is asked is the resistance of a metal wire of length 2 meter. That means length of the wire is given, it is 2 meter and is 30 ohm. That is resistance R is equal to 30 ohms. That is also given. Next, what we need to find out? At temperature 250 degrees Celsius. Here this temperature is of no use. We are not substituting this temperature anywhere. It is given just to say that temperature remains constant while doing this particular experiment. If diameter of the wire is 0.6, diameter is given how much? 0.6 mm. That is equal to 0.6 into 10 to the power minus 3 meter. Conversion of mm to millimeter to meter. That is, you have to multiply by 10 to the power minus 3. Then how to find out the radius? Radius equal to diameter by 2, which is equal to 0.6 into 10 to the power minus 3 divided by 2, which is equal to 0.3 into 10 to the power minus 3 of a meter. That is the radius. Then calculate the resistivity of the metal at that temperature. We need to calculate the resistivity. What is the formula? If you don't know the formula, you can just make the formula. That is resistance. We know that it is directly proportional to L, as well as we know that it is directly proportional to 1 by area. So I can write, by combining this, I can write R is equal to rho L divided by A. So this implies rho is equal to RA divided by L. So but rho, it is nothing but R is given, rho is nothing but the resistivity. R into A. How to find out? They have not given the A, that is area of cross section, but they have given the radius. So pi R square divided by L. So which is equal to, R is given how much? It is 30. 30 into pi is 22 by 7 into R square. R square is nothing but 0.3 into 10 to the power minus 3 whole square. That is by R square divided by L is how much? Length is equal to 2 meter. They have given. Now I will calculate this and I will write the final expression. So this can be written as, I can write this as 30 into 22 by 7. So I can write 30 into 22 into 0.3 into 0.3 into 10 to the power minus 3 whole square. That is minus 6 it is actually. So minus 6 it is divided by 10 to the power minus 6 divided by 30 into 22. So 7 into 2. 7 into 2 is 14. So this I have to simplify. So when I simplify this, what I will end up getting? So I end up getting 4.24. The answer as 4.24 into 10 to the power minus 6. That is the resistivity. What is the SI unit of resistivity? The SI unit of resistivity is A into R, that is divided by, so ohm meter is a ohm meter, that is a SI unit of resistivity. 4.24 into 10 to the power minus 6 ohm meter. That is the answer for this particular question. The next question which is asked is an electric heater of 500 watt. So that is given. What is watt? Watt means nothing but power. Power equal to 500 watt. It is 500. Operates for 12 hours per day. So operates for 12 hours. That is 12 hours per day. What is the cost of the energy to operate it for 30 days? That means total time 12 hours a day into for 30 days. So 30 into 12, it is equal to 300 plus 60. So 360. So it will be 360 hours. So 360 hours it will be operated. And so they are asking what is the cost. So cost per kWh, that is 1 unit, is given how much? 4 rupees. Then we need to find out how many kWh. How to calculate the energy in kWh? kW, kilowatt hour. Watt into hour we have to multiply. So energy is equal to the power into time, which is equal to power. Power is 500 into, that is 360. How to find out? 360 into 500 is 360 into 5. It is 3600, half of it. So 1800. 1800 0. So I can write it as 180 kilowatt. So I can write it as 180 kilowatt hour. So which is equal to 180 kWh. So what is the cost? Cost of 1 kWh is given. kWh is 4 rupees. Then what is the cost of 180 kWh? So the cost of 180 kWh is 180 into 4 rupees, which is equal to 36, that is 720 rupees. So answer is 720 rupees. Thank you.